Good morning, dear students. My name is Ferhan Mazher, and today is 21st of February 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. This is Cambridge O levels physics, and we are working on the solution of the past papers. And we are working on today on an alternative to practical ATP paper. We call it paper 4. The time allowed for this paper is 1 hour. So let's start today's paper, and let's open the paper. So here you have that paper, question paper. So this is October, November 2021 for one paper, alternative to practical paper 4. 1 hour is allowed. So the first question is coming up on your screen. He says, a student investigates how the period of a pendulum depends upon its length. So here we have a retort stand, that is boss and the clamp, and here we have you see pendulum. Pendulum is basically a thread, and at the end of the thread there is a metallic bob, and this is the center of the pendulum bob, and this is where it has been hooked. Where it has been clamped actually. So this thread, this pendulum can swing. This pendulum can swing. Okay. So we want to know that how much is the time period of this pendulum. We will check the length and we will note down how much is the time period of this pendulum. And this is the bench. Okay. So he says that the student arranges the apparatus as shown in the figure 1.1, clamps the string of the pendulum in position. The length of the pendulum is the distance from the center of the pendulum bob to the point of the support. So from the center of the bob, this dotted line you can see, to the point of the support. Okay, so that's the length of the pendulum. And he says, measure the distance L on the figure 1.1 to the nearest millimeter. Record your results. Important word is measure. Measure means use your scale, a rule, and measure it. So we will measure it with the help of the scale. I have done this because I hope that you have the hard copy of this paper. So I will place a scale here, and I will check how much is this length in centimeters. Okay, and then I will record that length here. So let me show you. So here we go. So here we go. So I have measured that length, and it is approximately 5.2 centimeter. So this is how you will enter that value. So let's go back to the question paper. Okay. So the next thing they are asking is figure 1.1 is drawn to a scale of 1/8. 1/8 means 1/8. 1/8 means that on the paper, the length, which is 1 centimeter, in actual, it is 8 centimeter. That's the meaning of this scale. The scale is 1/8 of a full size. It means that something which is on your paper is 1 centimeter long. In actual, it is 8 centimeter long. So your length is 5.2 centimeter. So he says determine the actual length of the pendulum from the point of support to the center of the pendulum bob. You measured that length, and that was 5.2 centimeter. So 5.2 centimeter multiply 8, and that will give you the actual length. Let me show you. So the figure 1.1 is drawn to a scale of 1/8 of a full size. How you do that? Actual length will be 8 multiply 5.2 centimeter, and that will be 41.6 centimeter. So 8 multiply 5.2 centimeter, and that will be the actual length. That will be 41.6 centimeter. So let's go back to the paper. So then he says, B part, the period T, capital T, is the time taken for one complete oscillation of the pendulum. One complete oscillation is one complete swing. For example, from the middle to one side, through the middle to the other side, and back to the middle. So that's one swing. Okay. So he says, Then he says the student adjusts the length of the thread until L is 15 centimeter, gives the bob a small sideways displacement and releases it so that it oscillates, records the time for 10 complete oscillations, repeats this procedure 2 more times. The following values of the time for 10 complete oscillations are recorded: 7.4 seconds, 7.8 seconds, 7.7 seconds. He says calculate the T10, the average value of the time for 10 complete oscillations, give your answer to two significant figures. So they have measured how much time it takes to complete 10 swings, and they did it 3 times. So they got this time. So if you want to find out the average of this time, this is the time for 10 swings. You will add these 3 values, whatever the sum is, divide that thing with the 3. So you will get, this is how you will get the average time. It's a 2 marks question. Let me show you. I have done this on a paper. So, okay. So 7.4 plus 7.8 plus 7.3. So I have missed a bracket here. So let me, here should be a bracket because here should be a bracket. Here I should have a bracket. Okay. So this is how it should look like. So bracket 7.4 plus 7.8 plus 7.7, bracket close, divided by 3 equals to, that will be 22.9 divided by 3, and that will be 7.63 seconds. So if I write the answer in two significant figures, he said the answer to give your answer to two significant figures. So 7.63, it has 3 significant figures. So if you want to write the answer in the two significant figures, so what we will do, 2, 7, and then 6. These are two significant figures. So after 6, there's 3. So just drop it. So you will have 7.6 seconds. So that's the time, average time for 10 swings. So I hope you understand. Okay, so let's go to the next question. Okay, so the next question coming up on your screen is, he says, this is the B, yeah. This is the B second part. He says that the student repeats the procedure in the B first for length L equals to 20 centimeter, 25 centimeter, and 30 centimeter, and 35 centimeter. The results are shown in the table 1.1. Complete the table 1.1 using your answer from the figure from the B first part. You will need to calculate T and the T square. So that average time which you calculated, that was 7.6 seconds. Just write it here, and then divide that time with the 10, and you will get the time period for one swing when the length is 15 centimeter. And then whatever is the time, just square it. So this is how you will complete that table. Then he says, explain why the student measures the time for 10 complete oscillations rather than one complete oscillation. Okay, so let me show you first of all the answers. Okay. So now you see that the time period for the 10 swings, the average time period for the 10 swings is 7.6 seconds. And so the time for one swing will be 7.6 divided by 10. So you will have 0.76, and then you have to square it. 0.76 is square, that will be 0.58. So hopefully you understand how this is done. So let's move to the next part. Okay. He says, explain why the student measures the time for 10 complete oscillations rather than for one complete oscillation. You see the time period is for the one swing is 0.76 seconds. The reaction time of the human is also like something like 0.5 seconds. So if you try to measure the time, or you try to time one swing, if you try to measure the time period for one swing directly, you see the reaction time in which you start the stopwatch and you stop the stopwatch. The reaction time of the human is 0.5 seconds approximately. So that reaction time is a very large as compared to the time period for the one oscillation. So that will create a large error in your measurement. To overcome that, or to reduce the effect of the reaction time, what we do, we never take the time for one swing directly. We always time 10 swings, 15 swings, and then we divide that time which we get with the 15. So by doing so, we take the average time for the one swing, and then it means that the effect of the reaction time will be reduced on the measurement. So the answer I wrote is one oscillation is too quick to measure the time period accurately. Measuring the average time for several oscillations is more accurate. So this is my answer. Okay, so let's go to the next part. It says on the grid in the figure 1.2, plot the graph of t square on the y-axis against L x-axis. Start your axis from the origin 0, 0. Draw the straight line of the best fit. So we have that table. And on the x-axis we will represent the L, and on the y-axis we will represent t square. So this is that grid given to us, and then it says determine the gradient g of your line, show your working, and indicate on the graph the values you see. Okay, so this is the 4 marks part in which we have to draw that grid. So let me show you. So here we go. So on your screen you can see here on the x-axis I have represented the length. This is 10 centimeter, 20 centimeter, 30 centimeter. Here I have represented the t square value. This is 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4. And then I have plotted the graphs. Okay. So I plotted the point. So here is that point for 15. Here is the point for 20. Here is the point for 30. Here is the point for 35. So I'm using this table. If you see from this table, this table, the L values are these are on the x-axis, and the t square values are these, which are on the y-axis. So the maximum value on the t square, we will have 1.39. It's starting from 15, and the maximum value is 35. So here we go. So here you can see I have plotted those points, and then I have drawn this blue color line is the line of the best fit. I have tried so that one point is above this line and one point is below this line. So this is the line of the best fit. You can also draw a better line of best fit, but I have done my best with the help of the mouse. So this is that 4 marks. You got 4 marks if you plot this. Then they say find the gradient of this line. So if you want to find the gradient, I took this point, I made this right angle triangle. This is called the rise, and this is called the run. So the rise is, if you will measure it, it will be 0.98, and the run is 23.5. So you just divide it, you got 0.042. So that's the gradient of this line. It's a very easy peasy question. I hope you understand. And so let's go to the part. What's the next part? Okay, so we are done with this. We are done with the gradient. Okay, he says that the theory suggests that the gravitational field strength G is equals to the G value is 0.39 divided by the G. We just calculated the value of the capital G. Just enter that value here. Use this equation and your value of the G in the B fifth part to calculate the small value for the small g. So whatever the value was here, just put it here and do the calculation. So you will have the G value here. So let me show you. Okay. So the 0.39 divided by our capital G value was 0.42. So our G value was 0.42. So when you divide them, you get this value 0.93. So 0.39 divided by 0.42 and you get 0.93. So this is how you do this part. Okay. In the next part, it says compare the value of the G you obtained in the B sixth part with the accepted value of the small g. Accepted value is 10 Newton per kg. The value we found is I wrote here 0.93. Let me confirm first of all. I think there is a little problem with this value. So let me check. Okay, so my dear students, we found a little mistake when I was typing. There was a typing error. This value was 0.042. Okay, so I wrote here 0.42. That was wrong. The actual value is 0.042. So when you divide 0.39 with the 0.042, you get 9.3 value. So that value, our value of the small g is 9.3 value. So I hope you understand. Okay, so the next part is compare the accurate accepted value is 10. Our value is 9.3. So this 9.3 value is close to 10. It's within the 10% of the accurate value. So our value agree with the accurate value. So my answer is yes, both values agree with each other. B7 part, the G value is within the 10% of the accurate value of the G. So our answer is right. Okay, so the next question. After this, we will go to the next question. And let me show you the next question. Okay, so the next question. Oh, but before going to the next question, let me show you the marking scheme. You can pause the video. Okay, so this is the marking scheme coming up for that question. So this is question number basically 1. This is question number 1, and the marking scheme with this marks is showing up on your screen. You can do one good thing. You can pause the video and you can take your time and you can read the answers. You can compare my answers with the marking scheme, and you can also, if you have written your own answers, compare your answers with the marking scheme. It's a very, very important thing to do that. So pause the video, take your time. So now let's move to the next question. The next question coming up on your screen is question number 2. It says the last question was of how many marks? It was of 14 marks. So let's go to the next part. It says, here we go. The question number 2. A student carries out an investigation to find the specific heat capacity small c of the copper. The student places a small block of copper on a balance to find its mass m, as shown in the figure 2.1. So they have placed the small block of the copper on an electronic balance, and the reading coming up on the electronic balance is 29.165 grams. 29.165 grams. So record the mass m of the block correct to 1 decimal place. So 1 decimal place means after the point there should be only 1 digit. So after the point there is 1. After that we have 6. So when I will drop them, I will write 0.2. So the answer will be 29.2 grams. So up to 1 decimal place, when you round it off, it will be 29 point. It will be 29.1. 29.2 grams. Sorry. And just record it. Let me show you. I have done this also. So here you can see on your screen, you can see I have noted down 29.2 gram. So let's move to the next part. The next part coming up on your screen is, here we go. He says the student measures, that's the B part, the student measures a volume of water in a measuring cylinder as shown in the figure 2.2. Record the volume V of the water shown in the figure 2.2. So this reading is how much? It is 41, 42, 43, 44, 45, 46. So it is 46 centimeter cube. So let me show you. So here you can, this is how you will write. It's 46, the volume of the water in this measuring cylinder, according to this measuring cylinder, is 46 centimeter cube. So let's move to the next part. He says, it says C part. The student pours the water from the measuring cylinder into a beaker, records the initial temperature of the water as θ1, and that's 23 degrees centigrade. So the initial temperature of the water is 20, it is 23 degrees centigrade. And he says places the copper block in the boiling water for several minutes until the block is at a temperature of 100 degrees centigrade. So he took the copper block, put it in the boiling water. So the copper block will also, after several minutes, the copper block will also become, its temperature will become 100 degrees centigrade. lowers the copper block into the beaker of water, and stirs the water until the reading on the thermometer stops rising. Then he takes that hot copper and put it in that beaker of the water, water beaker, obviously the temperature of that water will also rise. And when the thermometer shows that no more water temperature is rising, records the fire temperature of the water, which is 27 degrees Celsius. So he will note down when he put the hot copper in the water, the temperature with the temperature the water whose initial temperature was 23 degrees centigrade. Now the temperature of that water will increase to 27 because of the hot copper in it. The specific heat capacity C of the copper can be found using the equation. C is equals to V multiply 4.2 multiply 27 minus theta 1 divided by M multiply 100 minus 27. Use your results in A and B and the value theta 1 to calculate the value of the C. Give the unit in your answer. So this is how I will do this. So this is a very simple procedure. You see theta 1 was 23 and the M is 29.2. Just put these values here. So very carefully in your calculator, you will write 46 multiply 4.2 multiply bracket start 27 minus 23 bracket close equal to. So that will give you 772.8. In the numerator, you will write here 29.2 multiply bracket start 100 minus 27. And that will give you 2131.6. So you will equals to, so you will have 0.363 joules per gram per degree centigrade. So that will be the unit of this thing. Okay, the C value 0.036. So let me first of all make sure that this answer is right, because I think I have not. So let me see 0.036. Okay, so that is question number 2. 0.036 joules per gram per degree centigrade. So that's the answer. So our answer is right. Hopefully you have seen the marking scheme. Okay, so that is how. See, this is how this is done. Okay, so let's move to the next part. He says this method does not give an accurate value for the C. Suggest one reason for this. You see, when you do this, when you pour the water into the, when you put that hot copper into the water, lot of heat goes into the atmosphere, and by the process of evaporation also a lot of heat is lost to the surrounding. So that's why this method is not that accurate. That should not happen. So let me see. Okay, this method does not give an accurate value for the C. Suggests one reason for this. Heat is lost to the surrounding from the beaker. Heat is lost to the surrounding from the beaker. So this is question number 2, and it's D part. So the question number 2, I think, is completed. Then we have on your screen question number 3. But before you go on to the question number 3, let's take our time for checking out the marking scheme. So the question number 2's marking scheme is showing up on your screen. What you can do, you can pause the video and you can take your time and read this marking scheme very carefully. It is a very important habit to always check your answers with the marking scheme. Compare the answers with the markings. Very, very important habit. Okay, so I hope you have paused the video and you have read the marking scheme carefully. So now we are going to the question number 3. Okay, he says a student investigates the resistance of a thermistor. The student places the thermistor in a beaker of cold water, connects the thermistor into the circuit shown in the figure 3.1. So here we go. So here you have battery, here you have ammeter, here is that the symbol for the thermistor. Here is water, it's immersed in the water. Okay, so this is the beaker. On the figure 3.1, draw a voltmeter connected to measure the voltage V across the thermistor. So if you want to measure how much voltage is used here, you will draw a voltmeter here, which is parallel to the thermistor. So let me show you. I have drawn that diagram. So hopefully you can see that this diagram is showing up on your screen. So, oh my God, I have not drawn it. So let's draw this. That, oh, we have to draw that. So if you want to draw, here will be the meter. Okay. So this is how you will draw that voltmeter. That voltmeter should be parallel to the thermistor. Okay. So next question. He says the figure 3.2 shows the ammeter and the voltmeter readings when the thermistor is in the cold water. So when the thermistor was in the cold water, the reading on the ammeter, you can see this reading. Can you see that? It's 0.2, 0.1, 0.2, 0.3, 0.4. So 0.32, 0.34. So the reading on the ammeter for the current is 0.34 ampere. And reading on the voltmeter is this is 0, this is 1, this is 2. So this will be 1.5, 1.6. So the reading on the voltmeter is 1.6. So let me go to the next page. Okay. So 0.34 ampere is the reading on the ammeter, and the reading on the voltmeter is 1.6 volt. So let's move. The student adds some hot water to the beaker, stirs the water, repeats the reading of the current and the voltage. Explain why the student stirs the water. You see, whenever you have added hot water into the beaker, it already has some water. So when you stir it, you make sure that the whole body of the water has uniform temperature. The whole body of the water has the same temperature. So let me show you my answer. Okay. So by stirring the water, student makes sure that all the body of the water has the uniform temperature. So that's why they stir the water. Okay, to make sure that the whole body of the water has the same temperature. So then the next part is that the second part, he says the voltmeter reading does not change. The ammeter readings in the figure 3.3. Now the ammeter reading has changed, and the ammeter reading right now is 0.5. It is 0.56. The reading has changed from 0. The reading has changed to 0.56. So before, the reading was not 0.56, it was 0.34. But now the voltmeter reading has not changed, but the current value has increased. It has changed from 0.34 to 0.56. So you see the current in the ammeter has increased. How come if the voltage remains same, if the current increases, it means that the resistance has decreased. That's why the current coming from the battery has increased. Resistance R is given by the equation R is equals to V by I. State how the resistance of the thermistor changes as the water becomes hotter. You see, because when the water has become hotter, the amount of the current which is flowing through the thermistor has changed. Before it was 0.34 ampere, and now it is 0.56 ampere. So the current value has increased. And if the current value flowing through the thermistor has increased and the voltage has not changed, it means that the resistance has decreased. That's why the amount of current has increased. Explain how the reading shows in the figure 3.2 and figure 3.3 support your answer. So we say that the resistance has decreased. Why we are saying this? Because the current has increased. Voltage is still the same. So in the first situation, the R was V divided by I. The voltage was 1.6. The I was 0.34 ampere. So the resistance will be 4.7 ohm. In the second situation, the resistance will be V by I. The voltage is still 1.6, but the current has increased to 0.56. So that shows the resistance is 2.9 ohm. So 2.9 ohm means that the resistance has decreased. You see, this is how I've shown that my readings, my calculations. So that's the actual answer. Now I'm going to write. As water becomes hotter, the resistance of the thermistor decreases. Voltage in both situations is same. Both current in second situation, but current in the second situation is higher than the first situation. So the resistance will be less in the second situation because R is equals to V by I. If the V is the same and the I has increased, that means the R value will be less because the numerator is same, but the denominator has decreased. We are discussing this. You can show in your argument, you can write that calculation. You can show this calculation in your argument. Okay. So this is the answer. So the question number 3, I think, is completed. So let's go. Yeah. Question 3 has been completed. So let's. So my dear students, the marking scheme for the question number 3 is showing up on your screen. You can pause the video and take time, read this marking scheme very carefully. Confirm, check, compare the answers given by me. Also compare the answers which you have written with the marking scheme. It's a very, very important thing to do. Okay, so let's go to the next question. He says the figure 4.1 shows a cardboard lamina with 3 small holes and a piece of string with a small mass attached at one end. The string and mass together are called a plumb line. Describe an experiment that uses the apparatus shown in the figure 4.1 to find the center of the mass of the lamina. And he says, a clamp, boss, and stand, and a long pin are also available for use. Your answer must include a labeled diagram. So we want to find out the center of the mass for this. It's a very, very famous question, and it's a 4-mark question. Let me show you my answer. So what we will do? So it's here. Here, what I will take a retort stand. I will take a retort stand, and here with the help of the boss and the clamp, I will hold a pin, and by that pin, I will hang the lamina like through one hole. That pin will pass through that hole number 1. And when this lamina becomes steady, what you will do, you will take your plumb line and you will hang that plumb line vertically in such a way that your plumb line will be very close to this pin. So this string will be vertical. So along this string, draw a line on the lamina. That's it. So then hang the lamina from the hole number 2 and repeat this same process. Then hang the lamina with the hole from the hole number 3 and repeat that same process. Where these 3 lines which you have drawn along the thread on the lamina, where these 3 lines intersect each other, that point of intersection of these 3 lines, that will be the center of the mass. So this is how you write this thing. Okay. So here we hang the lamina through hole number 1 by a pin. Hang the plumb line such a way that thread of the plumb line coincides with the pin. So it's very close to the pin. Along the thread, draw a line on lamina. Repeat this procedure by hanging the lamina from the hole number 2 and then by the hole number 3. Where the lines drawn on lamina intersect each other, that is the point, that is the center of gravity of the lamina, or you can say that is the center of the mass of the lamina. So this is question number 4 and it's a part. I can hope you have understood. I can hope that you have understood this. Okay, so this is that question. Sorry. So let's go to the next part. He says, suggest how the position of the center of the mass found in the A can be confirmed using a sharp pin only. So what you will do, you will hang. What you will do, you will take a pin, and on the tip of the pin, you will put that lamina in such a way that the pin is exactly under the center of the mass, and you will observe that on the tip of the pin, that lamina will be balanced. Okay, so you are supporting the lamina only from with the help of that pin, only from that single point, and the lamina will be balanced. That shows that the center of mass which you have just found is correct location of the center of the mass. So I have written this answer also. So let me show you. It says lamina will be balanced if it is supported by a sharp pin placed under the center of gravity. All the weight of lamina will be supported by the head of the pin. Okay, so hopefully you understand. That is the question number 4, and it's B part. So let's go check. So we are done with this paper. Okay, so today, my dear students, we have attempted an alternative to practical paper. Today in our practice, we have done October and November 2021 for one paper. Alternative to practical, we call it paper 4. The time allowed was 1 hour. I have tried my best to explain you the concepts. The paper is very easy. I hope you have understood the concepts, and you also have understood how to write these answers. Okay, these are very famous questions. They have came in the Cambridge exams many times. Especially this lamina question, it is repeated many times. Okay, so if you think that this video has helped you, if you think that this video is helping you to understand how to attempt alternative to practical paper, please subscribe my channel. Also like this video. If you have any comment in your mind, please don't hesitate, write the comment in the comments. And if you think that this video can help your friends or your juniors or your seniors, share the link of this video onto your Facebook, onto your Instagram, and onto your Twitter accounts, because that will help me to promote my channel, and that will be oxygen, like oxygen to me. So I hope that I am to some help to you. So thank you very much. It's a blessing for me to be able to teach you online. Thank you very much. Have a good day, and God bless you all.